Very good morning, students. Today we're going to check one more algorithm of FFT, which is fast Fourier transformation algorithm, that is DIF FFT algorithm. DIF stands for decimation in frequency. FFT stands for fast Fourier transformation algorithm. If you decimate frequency axis, then obviously such an algorithm we call it as decimation in frequency FFT algorithm. Uh, it's almost the calculations remains almost same as DIT FFT algorithm, but the flow of DIF FFT algorithm is totally different when compared to DIT FFT algorithm, and today we're going to observe that particular algorithm through this video. Kindly note on this particular problem. This is what we're going to do it in today's session. Obtain an 8-point DFT of the following sequence using radix 2, which is nothing but base 2 DIF FFT algorithm. Show all the results along signal flow graph given x of n is equal to 2, 1, 2, 1. So this is the problem that was given. We need to obtain 8-point DFT, which means that n, that is length of a sequence, should be 8. But how to achieve DFT? It is using FFT algorithm. Which FFT algorithm? DIF FFT algorithm, and obviously radix 2, because as per our syllabus we have only radix 2 FFT algorithm. Given x of n is equal to 2, 1, 2, 1. As you are observing here, in x of n there are only 4 samples, but what is the length of a sequence should be? It should be 8. What are you going to do? Very good. We're going to add zeros. In general, we're going to add 4 zeros. As a result, your x of n will become 2, 1, 2, 1 followed by 4 zeros. What you are now guessing is 100% correct. Now we're going to solve this particular problem, that is to find DFT on given x of n, which is 2, 1, 2, 1, 0, 0, 0, 0, using radix 2 DIF FFT algorithm. You know that now we will use butterfly diagram in order to solve these particular problems. Since n is 8, in general, what is the first step? First step, we'll need to draw 8 lines, right? So we're going to draw 8 lines now. 1, 2, 3, 4, 5, 6, 7, and then 8. Kindly do the problem along with me so that now we both will understand. Once you draw 8 lines, what is the next stage? We need to combine signals, right? In DIT FFT algorithm, how did we combine? It's combination of 2 in the third stage, or if you start from left end, it is combination of 2 and then combination of 4 and then combination of 8 samples at a time, right? Here it is exactly ulta. That is, here we're going to combine all 8 samples, which will be the first stage, and then we'll combine 4 samples at a time, and then we'll combine 2 samples at a time. That is one major difference that what you can make out in DIF FFT algorithm when compared to DIT FFT algorithm. Along with that, in DIT FFT algorithm, as you can remember, input is bit reversed, output is natural. Here again it is reverse or ulta. That is, input is natural, output is bit reversed. That is second change that what you can observe in DIF FFT algorithm when compared to DIT FFT algorithm. Third change that what you can observe in DIF FFT algorithm when you compare that with DIT FFT algorithm is we used to multiply total factor term initially or at the beginning. Here we're going to do it afterwards, that is after the butterfly structure. These are the 3 major changes that what you can observe in the signal flow graph of DIF FFT algorithm when compared to DIT FFT algorithm. We're going to see all those changes while solving this particular problem when compared to DIT FFT algorithm. What was the first change I told? I told we need to combine all 8 samples in a starting from the left end. So we're going to do that first. That is, I should select a sample from a first line. Where that should go? It should go to fifth line, and then second to sixth, third to seventh, and then fourth sample to eighth. And we should also combine fifth sample, or we should draw a line from fifth line to where? First line, sixth to second, seventh to third one, eighth to fourth one. Now, what else I told? What is the second change I told? Input is natural order. And other one is total factor term has to be multiplied afterwards. So here I am multiplying total factor terms after the butterfly diagram. Whereas in DIT FFT algorithm, we used to multiply total factor terms before. Now we will use the same total factor terms that what we used in DIT FFT algorithm, that is W0, 1, 2, and 3. But the change that what you can observe here, that is in DIF FFT algorithm, is it has to be multiplied afterwards. That's what you are observing in this particular signal flow graph. Then remember, you need to append -1 to all downward arrow mark. Now, the same thing we also did in case of DIT FFT algorithm. No change in that. Okay, and one more change is input is natural order. See, you can observe x of 0, x of 1, 2, 3, 4, 5, 6, and then 7. Consider this as small x. Consider this as small x of 0, because we are what we are doing actually, we are obtaining DFT. Or what we're going to do through DFT, we will convert time domain signals to frequency domain. So in general, x of n, small x of n represents time domain, capital X of k represents frequency domain. Given signal is in terms of small x of n. Now, we're going to observe the first output, which is given by G1 of 0. As you can observe here in the top, we should perform addition operation. Which addition? Complex addition operation. G1 of 0 is given by x of 0 plus x of 4. What is there at x of 0? It is 2. And what is there at x of 4? It is 0. So what we need to do here is we should add x of 0 with x of 4, which is 2 plus 0, which is equal to 2. That will be a first answer. Similarly, what you will going to do to get G1 of 1? If in order to get G1 of 1, I should add x of 1 with x of 5. What is there at x of 1? It is 1. What is there at x of 5? It is 0. So 1 plus 0 is 1. What are you going to do in order to get G1 of 2? What you're thinking is correct. You should again add x of 2 with x of 5. What is there at x of 2? It is 2. What is there at x of 5? It is 0. So it is 2 plus 0, which is equal to 2. Think about what is the answer for G1 of 3. Okay, the answer that what you got is correct, which is 1. If you want to get G1 of 3, it is combination of x of 3 with x of 7, which is 1 plus 0, which is 1. Now, the interesting part will come now. Now, observe this carefully. If you want to get G1 of 0, you need to combine x of 0 and then other one is x of 4. X of 4 has to be multiplied by -1. That has to be subtracted from x of 0. The result that what you will get has to be multiplied by the two-letter factor term, which is W80. Now observe this carefully. G2 of 0 is given by x of 0, which is 2, minus what is that x of 4? What is that x of 4? Which is 0. Then close the bracket. The result, before that, one more change. This x of 4 value has to be multiplied by -1. 0 minus 1 is how much? -0. This has to be added with 2. What you'll get then? 2 minus 0. This result has to be multiplied by two-letter factor term, which is W80. What is the value of W80? It is 1. So as a result, you will get 2 minus 0. Did you understood how did I wrote, or why did I wrote -0 here? It is 0 multiplied by this -1, which you are observing along the same line. 0 minus 1 is -0. This has to be added with x of 0. The value of x of 0 is 2. So 2 minus 0. This entire thing has to be multiplied by the two-letter factor term. The reason why this entire thing has to be multiplied by two-letter factor term is, see, we have written two-letter factor term afterwards. As a result, we should multiply two-letter factor terms later. Can we check the next result? The next one is G2 of 1. How to get G2 of 1? It is x of 1, which is 1, and then -1 into x of 5. What is x of 5? 0. 0 into -1, -0. -0 plus 1 multiplied by the entire result has to be multiplied by W81. What is W81? It is 0.707 minus j 0.707. As a result, we'll get 1 minus 0, which is 1, has to be multiplied by W81. The answer is 0.707 minus j 0.707. Then moving on, the next answer, which is G2 of 2, can be obtained on a similar lines. That is x of 2 minus x of 6. What is that x of 6? 0. 2 minus 0 is 0. The final answer has to be multiplied by W82, which is minus j. This is what is important. That is, how you will write that particular bracket. That is what is important. Don't miss this particular bracket, because the answer has to be multiplied by, the final answer has to be multiplied by two-letter factor term. Since we have written two-letter factor term afterwards, the algorithm has to be followed like this. Then the next answer, which is G2 of 3, will follow the same steps. That is x of 3 minus 1 into x of 7, which is -0. The result is 1 minus 0, which is 1, has to be multiplied by W83, which is 0.707 minus j 0.707. And we will going to continue the same in the next steps as well. Here one change what you need to note down is W83 is not 0.707 minus j 0.707, but it is minus 0.707 minus j 0.707. As a result, the answer is minus 0.707 minus j 0.707. Shall we proceed with the next stage? If you have understood this stage, the next stage is almost the same. Whenever there is downward arrow mark, the resultant has to be multiplied by two-letter factor term. That is the logic. Complex addition, complex subtraction. While doing complex subtraction, the result has to be multiplied by the two-letter factor term. Try to combine 4 samples now. The next stage is here. I'll combine 4 samples. Here as well. Now for all downward arrow marks, you should multiply -1s. Okay, hope you understood how to combine this. What else we should do here? We should multiply two-letter factor term after. Here we will multiply two two-letter factor terms. One is W80, other one one is 882. So hope you are following. To all upward arrow marks, what is the what is the arithmetic operation we need to do? It is complex addition. So shall we check the answers now? P11 of 1 is given by G1 of 0 plus G1 of 2. G1 of 0 is 2, G1 of 2 is 2, 2 plus 2 is 4. P11 of 1 is given by G1 of 1 plus G1 of 3, which is again 1 plus 1, which is 2. Now, this is what is important. P12 of 0 is given by G1 of 1 minus 1 into 2, which is minus 2. So minus 2 is coming along this horizontal axis, whereas plus 2 is coming uh, from downward arrow mark. So 2 minus 2 is how much? 0, as to be multiplied by total factor term. The result, 0 multiplied by something is always 0, and hence the answer is 0. Next one is P12 of 1. Again follow the same steps, which is given by G1 of 1, which is 1, minus 1 has to be multiplied by this G1 of 3, which is minus 1. So minus 1 plus 1 will give you 0. 0 multiplied by total factor term, that is 882. Answer is 0. Shall we check the next answer? Next one is P21 of 0, which is given by G2 of 0 plus G2 of 2, which is given by 2 minus 2j. P21 of 0, which is given by G2 of 1 and then G2 of 3. So if you add here, real part will cancel out because at once you have minus, and the other case you have plus, so they'll cancel out, whereas imaginary part will get added up. As a result, you will get minus j 1.414. Now try this. P21 of 0 is given by, oh sorry, this is not P21 of 0, this is P22 of 0, which is given by 2 plus 2j. How it is 2 plus 2j? It is given by 2 minus of minus 2j, which is plus 2j. Entire thing has to be multiplied by total factor term, which is 880, which is 1. Then last answer is P22 of 1. Can you note this thing? This is P22 of 1, which is given by G2 of 1 minus G2 of 3. Answer has to be multiplied by 882. Hope if you work out, you are getting this answer, which is 1.414J. Whereas in the last stage, we need to combine only 2 samples at a time. So I'm going to combine 2 samples at a time. For all downward marks, what you need to do, we should multiply by minus 1. And then total factor term, which is 880, has to be multiplied afterwards. So follow the same steps. To the upper order mark, it is just addition, whereas in downward order mark, it is complex subtraction. Hope you have understood how to do complex subtraction. Now I don't explain this. X of 4 is given by P11 of 0 minus P11 of 1, which is 4 minus 1 into 2, which is minus 2. 4 minus 2 is 2. The result has to be multiplied by 880, which is 1, which is 2. So as you are observing here, output is bit reversed. Follow the same steps, we get this answer. Hope you have understood this particular problem.